So I decided to prepare a video of this nature. But before I bump into the video, I want to put certain information straight in regards to this question. One thing that I want you to have right at the back of your mind is this. This is one of the most favorite OBJ questions that regularly drops in your objective. For the past 5 years now, there's a single question of this nature that regularly drops in your general mathematics OBJ. So you must have it done if you've not yet. Be rest assured that the marks are for you, because you know no matter what they'll drop, right? And you must make sure you know how to work out their solution and the equation that has this root. But to you, this seems complicated. How to begin, right? This I will have to solve some rational functions in the next video. But what I want you to understand, no sooner you have a question of this nature, automatically what you should think about is taking the reverse as to approach a quadratic equation, right? A linear equation cannot give you two answers. A binomial linear expression or a trinomial linear expression, or either, let's say, a four polynomial expression cannot also give you two solutions. These guys want from you, right? You should keep track of that, please. Let's go now to the video. Use the same principle, right? Just believe in the matter. This is what I often tell students. Don't be carried away. You just need to know that it is x having these answers. So we're going to have x to be equals to the first guy that we have here, which is 2/3, comma, and x, which is minus 4/2. So these are the two answers we're having. We're just taking the reverse to get the equation of the line, right? So what we do from this point is to move this expression to this side and then set it equals to 0. We're going to move them over here. Remember, I had an equals to sign here, so we'll move with it to set it equals to 0. So we're not going to have x minus 2/3. Remember, this is plus 2/3. When it jumps the equals to sign, it becomes minus. And we have here a -4, right? -4/2, please. So when we move it, we'll have the expression to be x plus, this is -4. When it jumps, this is -4/2. When it jumps the equals to sign, it becomes plus 4/2. And at this junction, I'm just going to group them now in brackets, and now I'll FOIL everything out. I'm going to distribute everything. X times x will give me x squared, so I have here x squared, and then x times 4/2 will give me plus 4/2x. And then I'll move now to this guy. Minus 2/3 times x will give me minus 2/3x. And then if I expand that -2/3x again by 4/2, which will give me the expression down here, minus 2/3 times 4/2, right? So this into itself is 1 times 2 cancel off, so I have now minus 4/3, right? That's what I'm going to be ending up with. So we're just going to take this and then fill it in here. So we have -4/3, right? This is what we have presently to work with. So let's clean up some room. I'll try to simplify these x terms, since they are x terms, and I'll have to sum them up. Remember, this plus sign here belongs to this 4/2x, right? So what I'm going to do here is I will drop down the x square, and I'm summing out this. If you sum out this, you find the LCM is going to be 6 down there. 6 into 2, I know 6 into 2 will give me 3 times 4 gives me 12, right? And then 6 into this 3 here will give me 2 times this will give me 4. 4 plus the 12 that I've got here, I have plus 12 here minus 4 will gives me 8. So I'm going to have 8x over 6, and then I will take this time around. So I've got 8/6x. I will just take up this last expression here that is not having x, that's my constant, my c value, minus 4/3, all to be equals to 0. If you have doubt how I got this 6/8, please PV me privately so that I will teach you on how to sum fractions, right? The sum and difference of fractions, you need to have a common base, a common denominator. You must have an LCM of the two base, right? That's a choice on your part. You can decide to multiply 2 times 3 will give you 6. The LCM for 2 and 3 is 6. Either ways, right? The choice is on your part. So I will now have x squared, and then remember here is supposed to be plus 8 over 6 x minus 4 over 3 is equals to 0. Now at this stage I want to get rid of my fractions there. So what I'm going to do is I will have to multiply everything there in this expression. I will multiply it by the LCM that I have. For 3 and 6 is 6, right? The least common multiple is 6. So I'm going to have now the equation as 6x squared, and then if I do multiply, 6 times 8 will give me 48. 6 times 8 will give me 48. Divide it by 6 is 8. 6 times 8 will give me here to be 48. 6 times 8 will give me 48. It will give me 48. If I divide it by 6, it will give me 8, right? It gives me 8. So I'll have plus 8x, and I multiply 6 times 4 gives me 24. Sorry, if I multiply 4 times 6, 4 times 6 will give me 24, right? 24 divided by 3 will give me minus 8. This equals to 0. This is the equation that has the two roots you are seeing up here. The equation that has the two roots you are seeing there, which is 2 over 3, comma, negative 4 over 2. The equation is 6x squared plus 8x minus 8 is equals to 0. This is the equation that has the roots, right? This is a choice on your part. You can decide to say, okay, at this junction I've got the equation of my line. You are still done. I'm just trying to simplify to make things better. That's why I decided to push as far as removing the fractional aspect of this equation. And I just want to eradicate the rational expression, meaning the fractions. I don't need the fractions, right? Instead, I decided to multiply by the LCM of the denominators of the fractions. The LCM of 6 and 3 is 6, right? I multiply by 6. 6 times 8 gives me 48. That 48, dividing it by this guy here, gives me 8. And then I multiply 6 times x squared, gives me 6x squared. And then 6 times this 4 gives me 28 divided by, gives me 24 divided by 3 is 8. So this is a choice on your part. You can decide to stop here, or you can decide to go as far as this point is concerned. All I want you to get right is they are expecting you to build the equation that have these answers. So the answers we have when we solve these expressions are these guys. So we call them roots. They will not tell you these are the quadratic answers. Find the question. No, they will just say find the equation that has the roots, meaning they've given you the answers. Just find now the question. Stay blessed.